head. If you want to reverse this, let's call this data 1 and data 2, n1 and n2. N2. So your n2 will start pointing to this guy. So it is n1 next, or node 1 next. Node 1 next is pointing to node 1. And node 1 next will point to. So now this one become head. This one has to go down. So null. So just that. So your head next points to head, and your head next points to null. Okay. Now we swap only these two. We want to swap everything after this. So what is after this? Your next. Right? So I'll start swapping from here, so that everything after this comes back to me already reversed, and then I'll reverse this guy. Because then this will be pointing to null. I'll say don't point it to null, point it to this guy, I'll make it point to null. Okay? So I'll say reverse. So reverse node next. Now we need to handle the return value. What will be the return value? Have we written a main function or a driver function for this? So this one has to return the head, correct? The new head. So what are we returning? Node. In this case, what will we return? There is no head, but there is no head next. So either your head is null, or your head's next is null. So if I were to write null, and there is only one node, then it becomes wrong. So return head. I need a return here as well. Okay. What shall we return? Okay. Think of it this way. You have reversed this whole list, correct? This node is remaining intact. This whole list is reversed. So when it comes back, it's giving you the head. So when I've recursively called this and my recursive function has returned, it has returned me the new head wherever it was. Sorry, let's call it something different. For telephone, I think the recurse was a part of work. These two usually come together, because while you are doing something, you either have to call the recurse function, or while you are doing something, you encounter a break condition. Yes.
It's like node star root is equal to reverse, right?
Yeah.
So we are getting whatever was reversed into root node.
No, you are getting the new head. Oh, sorry. Let me write this as root. So let's say you had this when you started off, right?
Right.
This was your head. You are saying that this is the root, or yeah, this is the new root, or this is the new head, whatever you want to call it.
Right. We
Correct?
reach to the end and
Now you reach to the end. Okay. So this is where you have reached to the end. Either head is null or head next is null. At that point in time, you are saying, hey, return this because this is my new root.
Right.
So you return the new root.
Yes.
So your reverse is returning the root for you.
Yes.
So you are taking that root and saying, whenever I return at the end, I have to return this as my new head.
Right.
So whatever this one is returning is the new head.
But before that, the operation that we are performing, that should be on root.
No,
It should be on head.
because you are, okay, you are performing it on this particular thing. You are switching these two, but still the root is still the same. The root never changes. Okay?
Yeah.
When you are recursively going inside over here, yes, you are going to return this particular root, but at the end you still want to return this guy.
You know, like I have this slight variation of this one.
Okay. Can you solve?
Maybe I can share, yeah.
Sure. Yeah, definitely.
Maybe I thought like it might be a little bit easier.
Sure.
So,
Okay.
Oh, okay. I thought I could have compared it.
Okay.
That's fine.
Same.
That's fine.
Sure.
Right in the middle.
You can erase that. This part. This one is just.
let's keep it. I'll probably try to fit over here.
Okay.
So, like instead of having one pointer, if we can have two pointers, like think of we have this linked list. We start from head. So we keep looping through all the way end, but we actually, while we are looping through, we actually create one more pointer. So we have previous pointer, which is null. So on each step, when head moves over here, we move p over here.
Are you solving using recursion or?
Yes, recursion.
Okay.
I'll write the code and probably it will make more sense. So, like the signature actually becomes a recursion. We have head pointer and the previous pointer. So, for the first time when we call, we'll pass the head and we'll pass the null. To be like on this page.
Yep.
And then we have our breaking condition. And over here, what we're going to do is, let's say, we're going to call the recursion method. And we'll say head, next, like move head from here to here. And at the same time, the previous actually becomes head. So on each step, you see like head comes over here and the previous.
Yep. You're taking two at a time.
Right, and then it's like head, next, equals to previous. I think that actually solves it, makes it a little bit simpler. Like it's like 3 lines of code. We're doing the same thing, just having an additional previous.
Okay. So what will be your break condition?
Break condition will be like similar. Like if head actually gets to null, if head equals to null,
If not head.
yeah, not head.
Return what they should
What will be your return
say. What are you
value?
returning?
Head white, right? You do not return anything. So this is actually
So
just
how will you get the head, the new head?
So whatever was the new head, that will
So
still
the
be
last thing when you reach here,
right.
you're returning, correct? So you need to return this guy.
You need to
You
make
need
the
to return
M
previous
head.
at this point in time.
Yeah.
So what you can do is you can have a global variable that says
No,
M head.
there's already a global variable. So we can just say
Yeah.
m head is already
M head is
there.
already there.
So you can just say over there
Point
m
this.
head is equal to previous, and then you can say. We'll probably I'll solve this question and like try it out on my machine after this class, and I'll send this solution. Okay? Yeah. We'll see if this works. And yeah. Thank you. Thank you. Okay. So.
No, go ahead.
Okay. So there is another question which I was. Let's do a merge sort first. Let's do a merge sort first, and then there is another question which is that. Okay, so the question is that there is a linked list and the even positions, the odd positions are these. So this is 1, 2, 3, 4, 5, 6, right? So what you have to do is you have to actually take the even odd positions one and arrange them in ascending order, and the even positions you arrange them in the descending order. So let's give me some numbers. I don't know, any number.
5,
5,
7,
7, 8, 12, 1, 4. Okay. So the even positions, if you see, the odd positions is 5, 8, 5, 8, 1. Yeah. So in this, you
What? It's like
the odd position,
positions, okay.
position. So odd position one is 1 and 3 and 5. So 5, 8, 1. You have to arrange them in ascending order. So this will become 1, 5, and 8. Okay. And then the odd position was the even position was 7, 4, 12. Sorry. And 4. So this you have to do it in a descending manner. So it will be 12 and 7 and 4, right? And then you have to arrange them so that it becomes 5. It becomes 1, 12, then 5, 7, 8, 4. Yeah. So, do you guys understand the problem? Yes. Yes. Okay. So, I will make. Okay. So I'll do the merge. Like I don't know. Like I saw this question yesterday. I didn't get a chance to solve this question, but from looking at it and from what we have done earlier, what we can do is we can have two buckets. One will take the even and one will take the odd. So we'll have even one will be this, odd one will be this, and then we can call a merge function, which will merge sort, which will merge these two, and then after that we will merge both of these lists. One will take from here, one will take from here, one will take from here, and that will solve the problem. Yes.
But merge sort will sort, right?
Yeah. So you have to, once you have broken this, then you have to sort this out, right? So this was broken, now you sorted it.
Okay.
So now you sorted it in an ascending order. This one you'll sort in descending order, and then you'll merge both of them, right? So I'll do the merge sort for the linked list, and then I guess you guys can cobble together everything that you learned, and we can write the solution for that. Okay. So it's okay. So merge sort, we'll just like we haven't done searching and sorting yet, but we'll do 6. Let's say 6, 5, 3, 1, 8, 7, 2, Okay. This is a list and we have to sort it. So how does merge sort happen? Is like basically you break everything in individual components. Okay? So now everything is broken. Now you start merging 2 at a time. So you merge 6 and 5 and figure out what should come. So in the first position you will compare 6 and 5. Which one is smaller? 5. So 5 comes over here. Then 6 comes. 3 and 1. 1 is smaller, so 1 will come and then 3 will come. 8 and 7. 7 will come and then 8 will come. 2 and 4. 2 and then 4. Right? Then you will merge these two. So what will happen? You start from here. Start from here. 1 is bigger, smaller, 1 will come, and then 3 and 5, so 3 will come, and then 5 will come, and 6 will come, right? Out of these two, 2 and 7, 2 is smaller, 2 will come, 4 and 7, 4 is smaller, 4 will come, and 7 and 8, okay? And then you merge these two. So 1 and 2, 1 is smaller, 1 will come. 3 and 2, 2 is smaller. 4 and 3, 3 is smaller. 4 and 5, 4 is smaller. 5 and 7, 5 is smaller. 6 and 7, 6 is smaller. And then 7 and 8. Yes? This is how the merge sort works.
So is it recursive?
Yes, it is going to be recursive. So if you think about the solution, what happens is you actually have to split the entire list first. So there will be a function for split. Then there is a merge sort function. The merge sort function will actually take the head of the list, and then that will call that will first start splitting into 2 halves. Once it is done splitting, then it will actually call a merge function which will merge those 2 lists, right? So we'll have a merge function, we'll have a merge sort function, and we'll have a split function. So I'll start with the split function, which is easy, and you guys have written the split function. So a list node star a link list colon split and a list node star node. So what this function is doing is, if there is a node, it will go to the middle and it will break and it will return the second part, and the first part is already broken because we are breaking at the middle of that. Okay. So first we will check if not node or not node arrow next. So which means that if the node is empty or there is just one single node, there won't be a second part. So we'll just return null. Okay. Then we'll take the simple thing that we did yesterday, a list node star back is equal to node star front is equal to node, and boolean switch is equal to true while front exists if switch front is equal to front arrow next, and switch is equal to false, and we will call this comma boolean switch. no, sorry. I don't know. I started thinking. Sorry. I started thinking in a different way. Sorry. Okay, so switch is equal to false. Otherwise, we will increase the front as well as the back. So we'll say front is equal to front arrow next. Back is equal to back arrow next. And switch is equal to true. Okay, and it will actually front is equal to front arrow next. Yes. Okay. So once we are done, at this point, front has gone out and back is at the middle. So we will say front is equal to back arrow next and back arrow next is equal to null. So we broke the list and we are returning front. So we broke. Yes.
Please part of else.
Which one? Yes. Sorry. This is else.
What is the use of the switch in the parameter?
The switch in the parameter is like there is one condition in which it will, so either even or odd. Like what will happen is one time fast will actually, if you do fast is equal to fast arrow next, then it might break in one condition. Try it out.
No, we are not using that switch in the parameter.
Oh yeah, sorry. That's my mistake. I don't know what I started thinking. I started thinking about a different function. Okay, so yes, so that switch is not required. This is what it is. Okay. Yes. So at least, so we will call this recursively, and it will break the entire list into small individual pieces. Yes. Okay. Now we will do the merge. Sorry. Yes. So I'll erase this. Okay. So yes, is there something you don't understand? Huh? There is no then we will call merge sort. I can erase it? No. Okay. So we will have a list node second. So this is the merge sort, the first function that will be called. So we'll take a second part. So we'll say second, if not node or not node arrow next, then we just return null. Okay. Otherwise we'll say second node is equal to split of node. So if there's a node, we'll split. And then what we will do is we will return merge of merge sort of node, comma merge sort of second. Okay. So what this is doing is, if the node, if it is null, there is just one, and if it is 0, then return. Second node, we split it, and then we call merge sort of the node, because this was broken now, and the merge sort of the second one. So it is recursively calling itself, and then once this is done, we will call the merge function. Now I'll write the merge function. Yes? Yes, sir.
You should return node, not null.
Which one?
First case.
Yes, sorry. I think, yes. I think that is right. So, okay. So I will write the merge function now. Merge function is yes. I'm just looking at the signature. So merge function will take two nodes, first, comma, second. Okay. So while we are merging